Hi, this is Alex from devstories.eu. Async IO, episode 18 of 20. You hit a timeout fetching rows from a database. Your code handles the exception and moves on, but days later your application crashes because your connection pool is completely exhausted. You exited an asynchronous loop early, and it silently left database connections open in the background. The fix lies in mastering async generators and cleanup. When you write an asynchronous generator to yield items over time, you often manage resources. Consider a database cursor. You write a generator that acquires a connection, yields rows one by one, and uses a try finally block to return that connection to the pool when the fetching is done. If you iterate through every single row, the generator finishes, hits the finally block, and cleans up. Everything works. The danger appears when you do not consume the entire generator. If your iteration is wrapped in a timeout, or if you simply hit a break statement after finding the row you need, the generator pauses. It is suspended at the last yield. It has not reached the finally block. Your database connection is still held open. You might expect Python's garbage collector to eventually handle this. In synchronous code, when a generator loses all references and is garbage collected, Python injects an exit exception that runs the finally blocks. But asynchronous code complicates this. Garbage collection is a synchronous process. When the garbage collector eventually finds your async generator, it cannot reliably run asynchronous teardown code. The event loop might be busy, or it might even be closed. Relying on the garbage collector to clean up an async generator results in unpredictable behavior and dangling resources. This is the part that matters. The official async.io documentation explicitly states you should never rely on garbage collection for async generator cleanup. You must close them manually. The standard library provides a direct tool for this called aclosing, found in the context lib module. It acts as an asynchronous context manager. Its only job is to guarantee that the generator's aclose method is called and awaited the moment you are done with it. Instead of feeding your generator directly into an async for loop, you wrap it. First, you create the generator instance. Then you pass that to an async with a closing statement. Inside that context block, you run your async for loop. When you structure your code this way, an early exit triggers the context manager. If a timeout interrupts the loop, the async with a closing block catches the exit. It explicitly awaits the aclose method on the generator. This safely injects the exit exception into the suspended async generator while you are still actively running in the event loop. Your finally block executes immediately, awaiting any necessary teardown steps, and your database connection goes safely back to the pool. Whenever an asynchronous generator acquires network connections, file descriptors, or database locks, wrap it in a closing before iterating to guarantee deterministic cleanup, regardless of timeouts or early breaks. That is all for this one. Thanks for listening, and keep building.